All right, everyone, welcome back to Recap 2021. We have 3 sessions ahead of us, 3 really exciting ones, all given by SAP colleagues. The next one is given by Christian Georgi and Lothar. Both are part of the CAP tools team. Both are with SAP for a pretty long time already in the technology area. Lothar is on the first time on stage at Recap. Christian Georgi is a well-known fellow, if you know and follow CAP on several channels and stages in the world. They talk about schema evolution and tools. Very nice stuff, also quite complex and tricky stuff, as you know. So without further ado, I give over to you guys. Have fun.
So thanks, Sebastian, for the nice introduction. So let me share my screen. So you should now hopefully see the agenda, right?
Okay. Yeah, all good.
Yeah, okay. So actually we have a pretty packed agenda, and this talk will focus on different topics, all related to the CAP development tools. I will start with the schema evolution support and proceed with the custom development tasks feature. Christian will then introduce the CDS Linting topic. So schema evolution, what is it all about? Schema evolution deals with the ability of a database system that the schema can evolve while existing data is retained. Sounds a little bit theoretical, but in the demo, I think we'll see what this means. Actually, the schema evolution topic has already been touched in a former call. There it was in the context of Postgres support. This solution is based on Liquibase, which provides an abstraction layer to the underlying database platform. So now I will show the native schema evolution support for the SAP HANA database. It is available as a beta version with the latest CDS4 release. The solution is based on the HANA migration table type, which can be compared to a changelog file that's used by Liquibase. On the one hand, this gives you more flexibility in respect to schema changes, and on the other hand, it avoids the expensive copy operation for tables containing large data volume that would be carried out otherwise on every schema change in the HANA Cloud Edition. So multi-tenant applications, including extensibility, are also supported by this approach. Yeah, but let us see this in action. So I have prepared corresponding demo. So it's a very simple bookshop application, actually. So it consists only of 2 entities, the books and the authors entity, and it has been deployed to Cloud Foundry. So I've connected here my SQL tooling to the deployed database container. So here, these are the details. And now this allows me to introspect the content that has already been deployed. So the tables here, the authors table and the books table, and I can also see, okay, what content has been predefined. And here also can introspect the view, which is not of interest here for this scenario. So let's do a build, the HANA build, in order to create the HANA artifacts. You see, for both tables, we are using HTTP table artifact types. Let me close this. So now the idea is that I can annotate those entities that represent large volume tables or of other interest in respect to schema evolution. So you can do this later on at the point in time it is required. So we do not have to do this immediately for all the entities. So here I'm adding here this CDS persistence journal annotation to the books entity. For example, the assumption is that this is a kind of large volume table. So now if I'm doing a CDS build, what I'm getting here is, instead of the HTTP table for the books, I'm getting a migration table. And this actually is becoming a source artifact of my project. And also a corresponding season model is created which is also becoming source artifact, it represents the last development state of my CDS model. Let's deploy this to the database. So this is actually completely transparent for the running application. It's just a change of the underlying development artifact. So of course, the table here shouldn't change. Same structure, same data. Let us see. Refresh. We still have the data. Nothing changed. But now let's do some change here in this for the books entity. So I will add an additional field description of type string. Now let's do a build and see, okay, how the results look like. Checking here in my migration table, so I will open. And now we see that there's a migration version has been created. So, and this one contains one DDL statement. It's an alter table add this description column to the existing table. This is actually the corresponding table statement. It describes the final layout of the table. So let's deploy this, the database. And now I should be able to see this additional column. Let's check. Oh, still running. So to refresh, okay, I have the description column, and of course it's also here in the sample data containing some null values. But let us now do something more interesting, which was not possible with the standard deployment approaches using HTTP table or HTTP CDS. So now I want to rename this quantity field to stock. Let's build it and see, oh, okay, I'm getting an error here. And the error message says that some manual resolution is required. So this is actually provides me a link to the corresponding entity, which is the one I've already opened, of course. And here I am getting some comments and I see, okay, what has been generated here? So I see that the corresponding add statement has been generated by default for the stock and the drop for the quantity, which is obviously not what we want, because it would mean that the entire data contained in the quantity column would get lost. So what I need to do is I want to change this to a rename statement. So I want to rename the quantity column to the stock. So removing this one and also the corresponding comments as I'm done with this resolution. Actually, by default, we do not create drop statements, executable drop statements. So they are always commented out in order to make sure that you do not lose data by mistake. So let's now, so here is, I have the valid rename statement. Let's deploy this. And actually during the deployment process, so the HANA will check, so it will apply all the migrations that have not been applied at this point in time, and it will validate whether the migration result will match the corresponding table definition here. In case of any inconsistency, the entire deployment is rolled back. So this is also kind of safety net for you. So in order to avoid that data gets corrupted or lost by mistake. So now deployment is finished. Let's do a refresh. And we now see hopefully the quantity changes to stock. And we'll see here that now the stock column is containing the data, which is what we wanted. So, and this is actually all what schema evolution is about. So applying some changes to the schema while the existing data is retained, as mentioned in the beginning. So to wrap this up, I want to show a rough overview of the underlying architecture. So in here it shows what we did actually. So we compiled the CDS files to a season model, and this season model is now fed into a differ together with another season representing the last development version. The differ then calculates the delta and creates a delta model out of it. This is then getting transformed to corresponding SQL DDL statements that are now created, or the CDS build is then creating HTTP migration versions from these SQL statements and adding them to the migration table files, or creating new migration table files if they are not there. So the CDS build is doing the entire orchestration of that stuff. And as already mentioned in the keynote, actually, as an outlook, there are ideas currently to support Liquibase for schema evolution as a common abstraction layer for database platforms that are not natively supported by CAP. So, and the cool thing is that we can use the same architecture as a blueprint to generate here Liquibase changelog files instead of HTTP migration table files. So actually this brings me to the next topic, custom build tasks. Why might custom build tasks be of interest for you? They allow you to seamlessly integrate into the CDS build system. So in order to generate some CDS model related artifacts. So for example, you might want to integrate a specific runtime or a specific database platform we do not support out of the box. So we've also seen another use case in one of the previous sessions, TypeScript support. So maybe this might be an interesting scenario, right? Implementing a custom build task, generating the TypeScript for the current CDS model version. So we also support, for example, we also support profiles, so that you could even define different sets of build tasks for different scenarios, which is a really powerful mechanism. So here we're from copyright, we are already providing some built-in handlers for creating artifacts for Node.js runtime, Java runtime. So we've seen the HANA handler, which is doing the entire orchestration of the stuff, also creating all the other HANA artifacts. And we also have one handler that is creating artifacts required by SaaS applications. And now you could implement custom build plugins as separate Node.js modules. And these modules would then be called by the CDS build whenever CDS build is executed. Yeah. But let me show an example of a custom build plugin implementation. So for this, I prepared another project. Let's show this one. So this actually shows, on one hand, it shows the consumer side. So the bookshop application was consuming the custom build task. And here we have the custom build task implementation, which is at its core nothing else than a simple Node.js module. But first focus on the bookshop. So here in the package JSON, you see that we have a def dependency to the build task, to the custom build task implementation. And we have in the list of build tasks, we have configured this build task. Instead of using this for alias, we are using the use statement providing the fully qualified module path. And then you can pass any options you require for your specific task. So let me now execute CDS build. Okay, and I see now that this custom build task gets executed together with all the other configured build tasks. And you also see that we're already passing some defaults for the model options. So you can always override configure different or specific options than the defaults. But whenever possible, we are providing defaults. So of course, you could also execute this build task here using the dedicated path to this build task. So as we did, for example, before for CDS for HANA builds, this will only execute this build task. So now let's jump into the implementation. So it's very simple what you have to do. You are implementing a class inheriting from build class handler, and this one has two methods: an async clean method for doing some cleanup stuff of the files you have generated, and the build method. So let's assume normally that what you will normally do, I guess, in your build task, you want to compile a corresponding model. This is already what we are doing for you, and based on the model options that are passed to the build task. So here, whatever is configured here as model options, this is getting used as the input for the to find or the underlying CDS files. So we have the model compile, and now we enhance, or we are adding some additional query functionality by using the CDS linked, or the same than CDS reflect, to the model. And now in this scenario, what I want to do is I want to loop over all the services I have defined in my model. And for each service, I'm calling the mix generation in order to generate a Linux representation for this service. So passing the model and the service name and a message object here. So in order to retrieve any info or warning message from the compiler. In case of a compilation error, the entire build is aborted and the errors are logged. And now I'm then writing this ADMX to the file system, just simply passing relative file name. Or here, I want to generate this in the mygen folder. Of course, what you could do, you could access, for example, here the task object that has been configured here in the build tasks in order to access the properties, specific properties of your build task. So all the properties are also resolved, so the file paths. Or what you could also do, let's say you may want to issue a warning or error, build error you encounter. And this is then nicely formatted and logged to the console. And so let's just have a quick look at the clean method, what it does. Here I'm simply removing the mygen folder. So the clean method gets called before the actual build method. So now let's execute the build. Let's resave this, execute the build. And now I see, okay, this is now the build result. So we have the build results from the HANA task and from the Node.js task. And now this is the one from my custom build task. And it's a OData-v4 representation of the ADMX of the service description, which has been defined here. So I think that's pretty cool. And only with a few lines of code you can generate this stuff. So having said this, I want to hand over to Christian for the great CDS Linter feature. So thanks. Stay tuned.
Okay, thanks, Lothar. Let me real quick continue with one more thing from the tool side of the house, which is CDS Linting. We didn't want to miss the opportunity to show you what we've been doing for quite a while internally here, which is provide basically your possibility to execute static code checks on CDS models, right? So we've been asked for, I don't know how long, even from the beginning on, where is code inspector for CDS models? And you might know like the ABAP code inspector from the ABAP side. And we chose ESLint here basically to do that, to allow that as a framework. Again, why? Because we want to give others the opportunity to add context-sensitive checks to projects, to execute recommended check, but also add own ones, and basically to help increase the code quality. So that's the overall goal, so to say, right? So yeah, we did that through a plugin to ESLint, standard ESLint plugin mechanism, and by that like can benefit from all the nice infrastructure of ESLint, the tool support, etc. Right? Yeah. Before I will any more talks, let me just show that to you. I've opened the S-Flight application that we recently released with the Fiori colleagues, and I want to lint that. So how would I do that? There is first an add lint command. We use CDS add always to like configure projects, to prepare projects. Doing that, the lights go on to on the project, so to say. We all get in more of the warnings that we all love as developers. And what we see here basically is a couple of warnings telling us that someone doesn't like our naming convention here, so we recommend the lower camel case elements style, while that project seemed to have chosen the upper camel case naming convention style. I think probably because it was copied from ABAP, so I don't know. Anyways, so that's what we got out of the box, right? So that's a CDS model. It's not like a JavaScript file, right? It's a CDS model. And now, of course, I can also show that on the command line. So that's like for all the CI systems, CDS lint is the command to execute. It gives us the very same amount of messages. And what you see here on top is, by the way, just it tells you that CDS lint is just a wrapper around ES lint. It just to make it more a bit more convenient. You see, like otherwise we would have to like let you choose a formatter and the CDS extensions, etc. But you could also use ESLint command line for that matter, right? Now let me quickly pick that ID here, because actually now as a developer on that project, I want to disable that check. By the way, ESLint RC is probably known to you. So that was what CDS add lint initially configured. Yeah, it added just like, okay, the SAP recommend checks. And here I can just like elements, I think it is, and say that's off, and that all of a sudden all our lights go off again, right? So that's what we want to have, nice and clean. And I think also in the command line, that should be clean. All right, cool. So that's like executing recommended or like standard checks. And second one is reconfiguring existing checks in terms of severities. So that's what we've seen. Now let's quickly shift gears and add our own rule. We do that also with CDS add lint dev. That's done. And what you see basically here, it has printed out, there's a no entity moo rule in our project somewhere, and I think it's over here. And if you go inside the rules directory, you exactly find that. You also find even a unit tests generated for that rule. And you also find some documentation. Real quick look inside that one. It has okay, there is that entity, that rule, and it says we don't allow any entity called moo. No mooing in the project, so to say. It gives us a positive, correct, so to say, example, and of course an incorrect example. And I will just copy paste that one real quick and go in here at the end of our file and paste that in and complete that. And yeah, sure enough, it's red and saying, okay, moo is not allowed. I can even do a quick fix on that thing if my that ridiculously resolution allows me to do that. Yeah. And say fixing. So that rule implementation obviously chose to rename that to moon instead of moo, right? So that's our little gag here. So real quick on the logic. So what you see here basically is pretty much standard ESLint rule implementation. So no like big news apart from the core logic. So some rule factory, and you create a rule, and you have some rule metadata that basically we can generate the documentation out of. You know, this is like this literate documentation approach. And then you would have your standard ESLint context with the standard ESLint APIs and information. Plus, we added a little CDS helper object for you that allows you to gain access to all the APIs. So we basically here check. So in that function, we check for CDS file, for browsing through all the entity and checking if the entity name is removed, right? So that's a trivial thing. And the rest of that bit here is just is concerned with like providing that fixer, right? Some text calculation, etc. But apart from that, it's not more than that, right? So I think it's pretty simple implementation, but shows you quite a lot of things. and you can have a look at that if you want to later on. So closing that, we want to use the opportunity to show that to you when it will be released very soon, in the summer, I hope. And we will, of course, eager for your feedback, for your ideas. You can come up with your own implementations for your projects, or even provide ready-to-use packages for others as rules, right? That's also an opportunity, but just tell us in the questions what you think about it. Thanks so much.
Yeah, thanks a lot, Christian and Lothar. Well done. There were quite some questions, but Daniel was hardworking during your presentation and answered almost everything. I think there's one left which isn't answered. Yes. So the question was about Lothar's part. When adding the CDS persistence journal to an existing model, my assumption is that it becomes the version 0, and any new changes will create that migration file. Is correct? Yes or no?
So actually, when you annotate the entity, version 1 gets generated, and then you first have to deploy this initial version as a new matrix, as this HB migration table file, and then later on, all subsequent changes are creating migration versions, yeah, which go into the same migration table file. Not sure whether this answers the question.
All right.
So you have to do initial deployment, right, of the very first version before doing any additional modifications.
Perfect. All right. I think most or all other questions have been answered already. And if there are more, we can follow up in the after evening session. Thanks again to both of you. We go for a short break and then we continue with the next session.